All right, so this is 3.3, day 3, another way to graph the parabola by hand. Some of us touched on this the day before, but in case not, we're going to go through this extra little process. Um, so the way I like to look at these, this is another way using kind of a method similar to slope with lines. But if we had our parent function, right, normally we start at 0, 0. We would go up 1, or sorry, over 1, up 1 to 3. And we know our next point is at 4. And same thing for -1 and -2. And so you could think about this pattern a little bit. Is we start at 0, 0. We went over 1, up 1. Then we went over 1 more, up 3. And then over 1, up 5. And you keep this pattern going kind of forever. And it actually just keeps going as the odd number. So up 1, up 3, up 5, up 7. It has to do with the perfect squares, right? When we think about our numbers being squared, 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. 4 squared is 16. And in this pattern, we can see how as we move up 1, or to the right 1, we go 1, 3, 5, and 7. So that's the base pattern, 1, 3, 5, 7, and so forth. All right. However, if there's an a value, similar to always when there's an a value, it gets multiplied by the y. So we'll see that happen here as well. All right. This equation is a vertex in vertex form, so we can quickly identify our vertex as -1, -3, opposite of the inside, and then move it normal for the y. So -1, -3 is my starting point. Okay. So normally I would go over 1, up 1. So I'm going to draw the old one in green first. So if you don't want to write this down, it's okay. Over 1, up 1, over 1, up 3, over 1, up 1, 2, 3, 4, 5, over 1, up 7. 1, 2, 3, 4, 5, 6, 7. Okay. So that's where it would look like. However, for our graph here, we have an a value of 2. So it's not going to be over 1. It's going to be up 1 times 2. Then over 1, up 3 times 2. And it follows that pattern. All right, so my a is actually always being multiplied by that, how far up I go. So again, it's going to be over 1, up 2 now. Over 1, up. Normally I go up 3. Now I'm going to go up 6. So 1, 2, 3, 4, 5, 6. Okay. So hold up. I'm going to go over 1, up 2. Then over 1, up 3 times 2 is 6. So then I'm going to go over 1, up 5 times 2, which is 10. And this was really 1 times 2. So I'm going to go over 1, up 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now I can just, again, I mirror it. Same thing on the other side. Over 1, up 2. Over 1, up 6. And over 1, up 10. And there is my parabola. And we can see how that vertical stretch is happening quite a bit. You can see at this point, it used to be 2.6, and now we're all the way up at 2.15. So it's a lot higher. All right. All right, let's do another one with this pattern here. So again, I can pull out my vertex. It's going to be at 1, 5. And now that a, same thing, my a is -2. So it does the exact same idea. It's going to multiply it, but now I just bring that -2 with me. So again, I used to go over 1. Now instead of going up, I'm going to go down because it's negative, but it's still just going to be 2 times 1 is 2. So really it's like -2. Over 1 and then -2 times 3. Over 1, -2 times 5. And so forth. So over 1 down 2, over 1 down 1, 1, 2, 3, 4, 5, 6, over 1 down 10, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we just have the mirror image of those as well. And there you have it. So that's just that pattern again. It just so happened that our A values were 2 here. They could be anything. So remember, I'm not always just multiplying that pattern by 2. I just multiplied by 2 here because that's what my A is. So it's always the pattern 1, 3, 1, 3, 5, 7, 9, dot, dot, dot. And then you have the A out in front. So A times that, A times that, A times that, A times that, A times that. All right. And that is the first page, and then we'll get on to the next one.